Okay, so question 16 of this chapter 12. So we are given that y equals x to the power 3 over 2 plus 48 over x. Find the value of x and the value of y when dy by dx equals 0. So dy by dx. Okay, let's see now. Let's have a thinner pen on that. Is we're going to multiply by the old power, and we're going to do 3 over 2 minus 1 up there. This is going to be a minus 48 when it gets multiplied down by the minus 1, and it'll become x minus 2. So we end up with 3 over 2x. That's 1.5, so that's a half, minus 48x to the minus 2. When it equals 0. So we've got to solve that for 0. What do we have there? What does that look like? Nothing particularly nice, because that's 3 times the square root of x over 2 minus 48 over x squared. Okay, I guess what we can do here is we can try and get x on its own, because we've got to solve for x. So let's have a little look at what we can do. I think what we might do is, if we change the denominators to a single 2x squared or 2x squared, we can then try and multiply out from there. Okay, so changing this by x squared, we're going to have 3x to the half times x squared, and if we're timesing that by x squared, we are multiplying, we're adding up the powers, aren't we? Okay, and if we multiply the bottom by x squared, we get x squared, minus multiplying this top one by 2. Okay, what's that going to be? 96 over 2x squared, okay, equals 0. So with that all done, we can multiply out by the 2x squared, so 0 equals 3. Now then, the square root of x times x squared, if we were doing x squared times x to the 4, we would have x to the 6. You just add them up. So we have 2.5, which we can write as 5 over 2. X 5 over 2. Okay. Minus 96. And so 96 equals 3x 5 to the 2. 96 divided by 3 is 32. 32 equals x to the 5, 2. So we want to square 32, and we want to do the 5th root of it, because we want to do 32 to the power of 2 over 5 to equal x. Okay, and 32 to the power of, what was it, 2 over 5? 2 over 5 is 4. Right. With that done, we can substitute the 4 into the original equation, which was y equals x 3 over 2 plus 48 over x. And so putting in that value of x, we get y equals 4 over 3 over 2 plus 48 divided by 4. Straight into a calculator on that. 4 to the power of 3 over 2 is 8, plus 12 is 20. And so the coordinates of where it is, the coordinates of where dy by dx is equal to 0 is going to be 420. Okay, taking the two values there. Okay then, so part B, all right, show that the value of y which you have found is part of a minimum. So we know that if you have d2y by dx squared, if it is greater than 0 at a point of, in this case, x equals 4, then it's a minimum. If it was less than a 0, then it would be a maximum. Okay, so taking a value of this, which we got down to, what was dy by dx, here it is. Okay, so taking this 3 over 2 x to the half minus 48x squared. Okay, so dy by dx is equal to 3 over 2x to the half minus 48x to the minus 2. Okay, just double check that one. Yep. So d2y dx squared is equal to 3 over 2 times 1 over 2x to the power of minus a half minus times minus 2 plus 96 x to the minus 3. Okay, now when x is equal to 4, this is going to be, what's that on the top there? 3 over 4 times 4 to the power of minus a half plus 96 times 4 to the minus 3. Okay, so that's 3/4. It's 3 over 6, isn't it? 3 over 8 even, because square root of 4 is 2. 2 times 4 is 8, plus 96 being divided by 4 4s is 16, and 4 16s 64. Okay. So 3/8 plus 96 divided by 64, which is 3 over 2, plus 3/8 gives us 15. Gives us 15 over 8. Okay, that is bigger than 0, and that's what we want. Okay, so that is bigger than 0, which is d2y dx squared is greater than 0, so minimum. Okay. Okay, then on to question what are we on to? Question 17. Question 17, curve of an equation is y equals x cubed minus 5x squared plus 7x minus 14, determined by calculation the coordinates of the stationary points of the curve. Okay, so to begin with, we're going to look at the differentiation of this, dy by dx, and that's going to be 3x squared minus 10x plus 7. Okay, now what we need to do is solve 0 equals 3x squared minus 10x plus 7, and that gives us x equals, and x equals, assuming it's a quadratic, well, not assuming it's a quadratic, but it is a quadratic, so it should have two solutions. Okay, putting it straight into the calculator, polynomial solver, so 3 minus 10 and 7 gives us x at 7 over 3 and x at 1. And so what did they want us to do? Determine by calculating the coordinates of the stationary points of the curve. So we need the y values of that as well, since we need to do coordinates. So y equals 7 over 3 cubed, putting it back into the original equation, minus 5 times 7 over 3 squared, plus 7 times 7 over 3, minus 14. And that gives us, what do we have there? 7 over 3. 7 over 3, which I'm going to store as an x value. So x to the power 3 minus 5x squared plus 7x minus 14 gives us, what's that, a bit of a number, 12 minus 12 and 5 27ths. Okay. Then we're going to do 1 store as x. There it is. And if we go and put that back in, we get y equals minus 11. Okay, so coordinates then are going to be 7 over 3 and minus 12 and 5/27ths and 1 minus 11.